Okay, so welcome back to 7.4, adding and subtracting radical expressions. Um, Pretty easy section here, not too many questions, not too many examples, so we'll get it done real quick and then we'll move on to 7.5. Basically, the only objective is simplifying radical expressions involving addition and subtraction. So we do so by doing the distributive property. Basically, we take the radical portion and we pull it out, and then we combine the outside, whatever's going on the outside, we add or subtract those and then leave the radical portion alone. So, oops, sorry, let's kind of move that there. And then we'll go ahead and do A. So we're going to pull 3 plus 7 out, square root of 5, and we will have 10 square root of 5, and that's it there. And then next one, we will do 2 minus 3 square root of 7. That will give us a -1. You can write the 1 or not write the 1. I'm not going to write the 1 because you guys should get in the habit of not doing that. Here we have to do a step first. So the question I will ask you is, we need to get the radical, or the radicand rather, to be the same. So what you want to think about is, what do 12 and 75 share in common? Well, if you need to, you can look at the factors. 1 and 12. Wow, getting a little bit tired, I think. So 1 and 12, 2 and 6, and 3 and 4. Well, 75, we have 1 and 75. 3 and 25. Well, look at this, 3 and 3, and they're paired with perfect squares. So right there is what you want. You want to do radical 2 squared times 3 plus radical 5 squared times 3. That'll give you 2 square root of 3 plus 5 square root of 3. So 2 plus 5 square root of 3 gives you 7 square root of 3. Okay. Nicely done there. This part is very important because we weren't told that we have all positive numbers there. So we do need to have that same situation though. We want to think about, what do 63 and 28 share in common? That's actually a 7. So we will do negative square root of 63 is going to be 3 squared times 7t plus 3, which will be 2 squared times 7t. If you're having a hard time figuring that out, go ahead. I'm telling you, look at those factors. So the factors there are 7 and 9, and the factors here are 7 and 4. Perfect square, sevens match, good to go. So -3 square root of 7t plus 3 times the 2 square root of 7t. So that's going to give you -3 square root of 7t plus 6 square root of 7t, which is then going to be -3 plus 6 square root of 7t, which is 3 square root of 7t. But before we can say we're done there, we have to also include that t is greater than or equal to 0. Then we're done. Last part here, please take a note that our radicands are prime. So your only option between them is 1. So we are done there, and we have to say, unlike radicals cannot simplify. Okay. All right. I'll go back just in case you need to pause here and write stuff down. And then we'll move on to example 2. Okay, so for these examples, what you want to think about again are what are the perfect cubes or perfect force or groups for each problem. So let's take a look at A. We have a 3 on the outside, so we'll multiply that by whatever we bring out. And then we have 3 cubed. Now, 2000 is the same as saying 2 times 1000. Well, and then we have to have the second part. Then minus 4 times the cubed root of 128. Well, 128 is the same as 81 times 2. So then we would break these into 2 times 10 cubed minus 4 times cubed root of 4 cubed times 2. And then we can see that we're going to bring out 3 times 10 cubed root of 2 minus 4 times 4 cubed root of 2. The roots match, so it's just we're gonna bring these to be 30 minus 16 cubed root of 2. So we get 14 cubed root of 2 as our answer here. Okay. And next for B. So the first one's nice because we're just looking at exponents. So it's going to be a to the 4th times a, and then times b cubed. The b doesn't change. And it's the 4th root of 81. 81 is 3 to the 4th power. Yep, 3 to the 4th power. And then times a times b to the 4th times b cubed. And we'll pull out an a. We'll pull out a 3 and a b on the other part. So that's going to be 5a on the outside, 4th root of ab cubed plus 3b 4th root of ab cubed. Our radicals are the same, but our variables on the outside are not. So we're just going to bring together 5a plus 3b with our radical on the outside. So it could be easily distributed if someone wanted to do that. Okay, and the last one would be the cubed root of 128, and that's going to be 81 again, times 2, and that'll be times t cubed times t minus 2 square root of 36 times 2 times t squared times 2. To pay attention because we have an index of 3 and an index of 2. So those do not match. What we're going to end up finding out is that we have the same radicand, but that the radicals themselves are different because of the indexes, and we're not going to be able to continue with it, but we will still work it all out. Here we'll pull out a 4 and a t. Here we'll pull out a 6, multiply it by the 2 that's already outside, and a t. So we'll have 4t cubed root 2t inside minus 2 times 6t square root 2t inside. See, the radicands match, but the overall radicals do not because of the indexes. So we have 4t cubed root of 2t minus 12t square root of 2t. And that's all we can do there. There's nothing else that will let us continue. So different indexes. So can't combine. Okay. All right, and then I'll actually leave that there a second. So if you guys need it, you can have it. And then we just have one small example left for this lesson, and then we'll move on to 7.5. So we are looking at here. We want to find how we can get rid of the square root of 5 here. Well, what does 45 have in it that has a 5 and a 9? Well, the 9 is going to be pulled out, but we will write it like this for the moment. Square root of 28. 28 is 2 squared times 7 over 3 squared. So we can cancel here, and then we'll pull out. So this is a 5 on top, 3 on the bottom, minus 4 times 2 square root of 7. Right, and then we'll just finalize that to be 5 minus 8 square root of 7 all over 3. We were able to bring this together to be one fraction because square root of 3 squared is 3 and square root of 3 squared is 3. So those matched. Our LCD was the same. We didn't have to worry about anything there. Now, here is a different story. We have a 6 on the outside. Cubed root of 16, cubed root of x to the 12th. I'm going to go ahead and make some changes here. This will be 2 cubed times 2, and then x to the 12th, we're going to do x cubed times x cubed. That gives us x to the 6th, x cubed, x to the 9th, x cubed, that's x to the 12th, plus 7 on the outside. Cubed root of 9 doesn't change anything. Cubed root on the bottom though, x cubed, x cubed, x cubed. So we'll pull out 4 x's on the bottom and 3 x's on the bottom of that one. We're going to pull out 1, 2 on top of here. And then, like I said, the 7 stays the same over there. It doesn't change. So we would have 6 times 2 cubed root, of 2 all over x to the 4th plus 7 cubed root of 9 x cubed. We need an LCD of x to the 4th. So that just means that top and bottom here need another x. So that would make it 12, because 6 times 2, 12 cubed root of 2 plus 7 cubed root of 9. We need an x here, 7x over x to the 4th. And we're done. Right. And that's it. I will see you in a few moments for lesson 7.5. See you then.